What's up guys, welcome back to the channel, and it's been a long time since I made my last video. So today we are going to discuss about different components in electronics like transistors, LEDs, resistors, capacitors and more. So before we get into the video, make sure to hit the subscribe button and like the video, and let's get started. So first up we are going to talk about resistors. This is a fixed value resistor, meaning that the value of resistance cannot be changed, but this is a variable resistor and its value can be changed. So there are few types of variable resistors and fixed resistors. Uh, uh, these ones are called potentiometers. So we use these to keep it in a fixed value when we are tweaking a circuit, and we are not gonna change it again. So these ones are volume controllers. We use them to change the volume of a audio amp or something, and we use them regularly. So this is a multi-turn potentiometer, and it has more resolution than this potentiometers. This turns 360 degrees, and this has like 720 no this has more rotational points than this, and it has more resolution than this one. So you can precisely change the resistance using this multi-turn potentiometer. There is a bigger version of this which will appear here, and so these are used to limit the current flowing through a circuit. So the symbol for a resistor is this. This is one of the symbols, and this is the most used one. Since this one is hard to draw, students use this one for ease. And so there are more types, and there are variable ones dependent on temperature and stuff. So those are sensors. These are the fixed value and variable resistors. So let's get to LEDs. This is a LED. So it emits light when we give power to it, and so when driving a LED, you have to use a resistor or a current limited supply. We generally use a resistor, but when it comes to driving high power LEDs, you will need to use a current limited supply. So you can tell the negative and positive pins apart by the pins. The longer pin is the positive, and the shorter pin is the negative. So we also call it anode and cathode. So you see in a transparent LED there is a bigger part and a small part inside. The small part is the positive side and the bigger part is the negative side. And also there is another method to identify it. There is a little notch here like this. There is a little cutout here. You will feel it. It's the negative side. It's the minus. So when driving LED, you will need to use a resistor to drive it properly, or use a current limited supply. In when we use these as indicator LEDs, you won't need to use a current limited supply. So let's try turning it on. Here you go. It turns on like that. So the symbol for this is a triangle, and these two arrows pointing outward like this. This means it emits light, and this means that this is the negative point and the positive point is this, like that. And so let's get to relays. This is a relay. It has a coil and a switch. When you power the coil, it creates a magnetic field which pulls the switch on like this. When the current is flowing through the coil, it creates a magnetic field which attracts the switch and makes it a closed connection. So these relays has two pins, which one is for normally open and other one is normally closed, which means when there is no power, the normally closed pin is connected to the common pin, which is this, and the normally open pin isn't connected. So when you apply power, the switch goes from normally closed to normally open. And this is a basic switch. This is called a toggle switch. It's used for turning applications on and off. It's a basic switch. So the symbol for a switch is this. Two contact points disconnected from each other, and so let's get to capacitors. This is a capacitor, a bigger one, and let's get few other choices right here. So this is a capacitor. These are electrolytic capacitors, and these are Mylar capacitors. These ones. And also these capacitors. There is a two-layer type of these capacitors which are less dependent on the temperature, but in electrolytic capacitors it changes the capacitance value dependent on the temperature. I mean, it's not very accurate to use it in a high temperature environment if or near the components that gets very hot. So you should really consider that. And the capacitance is written on microfarads. So this one is written on J, and you can convert the J into microfarads. So you should probably Google that, and I will also put the formula here. And these capacitors store energy for a small amount of time and discharge it. Unlike a battery, it can only store a very little amount of energy, but unlike a battery, it can discharge in a small period of time, right? And now it has charge, and I can discharge the capacitor through this LED like this. I think you saw that. It still has some charge, you see. And let's try that again. charge and discharge. So these have a voltage limit, and this one has a limit of 6.3 volts, and this has a limit of 500 volts, and these are also polarized, which means you can't switch the leads, otherwise they will blow up, like in electrobooms.
To measure the AC output using my...
So this white side with this sign is the negative side, and this is the positive side. This is the negative lead and this is the positive lead. So now let's get to diodes. So LED is also a diode, which means current and voltage flows in one direction. The current flows in one direction and not the other. So the symbol for the diode is this. Meaning this is the anode and this is the cathode. So you can clearly see this one. You can see a silver stripe right here. It's the cathode, and the side which doesn't have the stripe is the anode. So this allows current to flow through cathode to anode and anode to cathode, but you can't switch the poles like this and the current won't flow. So let's take a smaller version of the we have so I have this there, which is a smaller one. Let's take the breadboard, and I'm going to light the LED with this there. I'm also going to add the resistor. So this is a good one. So as you can see, the current flows in this circuit, so the LED lights up. And let's switch the poles of the diode. I am not changing anything else, only the diode. So let's try that again. So the voltage does not flow here, and let's connect it properly. And again, also you can see the current is flowing. Also I can change the positive and negative rails, but as I said, LED is also a diode, which means current can't flow. So I'm going to test with the multimeter. Is there any voltage? Hope you can see the multimeter. So 0 volts. There is a little voltage, but it's not much. Yeah, very small voltage. So this can add a reverse polarity protection to a circuit that you make, and this has its breakdown limits, which means at a certain level of voltage it will break the barrier between these layers, and it makes the diode saturate, which means the current will fully flow through the diode. And also diodes have a voltage drop of 0.7 volts. 0.7 volts, and we can actually see that voltage drop using the multimeter. So let me show you. I'm going to connect the LED again. So if we measure between the diode leads, we can see the 0.7 volts drop. Let me switch to 2 volts. We can see the wait. It is not connecting. Oh my god. Yeah, let's measure between the diode leads. So you can see a 0.7 volts, a voltage drop right here, 0.73 volts. So if you use a diode in a circuit, it will add a drop of 0.7 volts. If you add 2 diodes, it will add a 1.4 volts voltage drop. So you should take that into account when you make very low voltage circuits. And let's move on to transistors. Let me take a transistor. This is a transistor, and its symbol is this. Transistor has two types, which is NPN and PNP. This is the PNP transistor symbol, and this is the NPN transistor symbol. This is the most used one, and this is the least used one, but we still use these PNP transistors. There is applications for them. There is times when we need a PNP transistor to do the job. And so these transistors has 3 leads. They are called base, collector and emitter. Like the LED, transistors also contain a diode, and you can switch the diode on and off. So I have a transistor, it's BC549, and I need to check the pins. I check using this component tester. Let's test it. So the first pin is the collector, and the second pin is the base, and the third pin is the emitter. So just as the diagram. So when we use transistors, we should use a base driving diode, because if excess current flows through the base, it could kill the transistor and burn. So you should use a current limiting diode like this. So in an NPN transistor, the base should be in order to turn the transistor on, you should apply a positive voltage to the base, and also the transistor has a 0.7 volt drop, and you will need to apply more than 0.7 volts in order to operate the transistor. So let's try turning an LED on with this. You can see the diode right here, so I should connect according to the diagram. As you can see, the LED turns on, but there is no connection directly through the base to the collector or emitter. The current is controlled by the base. So as you can see, when I apply voltage to the both sides of the LED, it won't light up. But if I apply voltage to the base, and the LED lights up just like this. Then we have the MOSFET. Let's take a MOSFET. This is a MOSFET. Unlike a transistor, this doesn't need current to flow through the base, so we don't need a resistor, and it only requires voltage. So the symbol for the MOSFET is this. I don't know, I actually don't remember that. So I'll put the symbol right here, and it contains a capacitor at the gate. So the 3 pins are gate, drain, and source. So when you apply a voltage to the gate, the drain and source pins will make a closed circuit. So there is a diode right here. No, there is a diode between the drain and source. Let's see that diode. You can put the multimeter to the diode mode. So yes, there is a diode, and let's see, there is a diode. So the diode should be reversed, meaning that it is like this. So let's try using a MOSFET. As I said, there is a capacitor, and the MOSFET doesn't require any current to flow through the gate pin, so it holds the position when I turn it on. Let's see that in action. Carbon stuff. Set it. Yes, yes. So it turns on, and even when I disconnect the power to the MOSFET and put the LED, and it turns on. Now I can short the gate pin to the source. Is this shorted? No. And Oh, yeah. So now it's not turned on, but when I cover the gate and it's on. So by discharging the gate, I can turn it off. So if you are using to uh, turn it on and off, you will need to add a resistor like a 10k resistor uh, through the gate and source pins to discharge the gate pin. So keep that in mind. And also MOSFETs are way more efficient than transistors. It has a very low resistance uh, through the drain and source pins, but the NPN transistors have a little bit more resistance in emitter to collector junction pins. So also there are these guys. These are just regulators, and they dissipate the excess power through heat. And this one is a 5-volt regulator. Now if you apply more than 5 volts to it, it will regulate that voltage to 5 volts. I'm going to apply 11 volts 11 volts right here. So you can apply the voltage to the first pin is the positive, and the middle pin is the negative, and it's the common point. And you can get 5 volts in the from the common pin to the third pin. See, 5 watts, 4.98. So these are regulators. They are labeled as L7805CV. So this is a regulator. And MOSFETs are commonly labeled as IRF. This is IRF 3205. And transistors, there are many numbers. And also you can find transistors in most of the electronic circuit boards, and you can find MOSFETs in UPS circuit boards, computer motherboard and stuff. But even though these look the same, they are different, and you would need to check the data sheet to know whether it is a MOSFET or transistor or a regulator, or you will need to use a component tester like this. I made it myself. You can also make one yourself. I'll put the link down in the description. And if you learned something so far, please make sure to hit that subscribe button and like this video, and see you with the next project. Until then, bye bye.